In this question, we have a sales representative who's based in city A and she's about to begin a journey by car to all of these cities in this order. That means she'll go from A to B first, then B to C, then C to D and so on till she gets to G. This is actually how you can see all of these parts of the journey as the headings on the columns of the table. Then we go on to describe the table. The table shows her estimates for the probability of encountering road construction for each of several routes between consecutive cities. So I can see that there are 7 routes from A to B because there's nothing in 8, 9, 10, 11. There are 9 from B to C, there are 8 from C to D and so on. So you have different routes, different number of routes between any 2 consecutive cities. And the table, as they just said, it shows the values that you see in the table. These are her estimates for the probability of encountering road construction. So if I talk about the first route from A to B, then the probability of encountering road construction is 0.1. If I talk about route 5, then the probability of encountering road construction is higher, that is 0.9. So we've understood the entire situation. Now, what is it that we have to do? The sales representative minimizes the probability, according to her estimates, minimizes the probability of encountering road construction during the course of her entire journey. So her goal is that I will select my routes in a way that I do not get too much road construction. I choose the routes where there is minimum chances of me finding road construction. Okay. So for each of these statements, we have to select if the statement is accurate and otherwise select no. If you found the analysis of this data set helpful, then hit that like button so that other GMAT aspirants can also learn from it. And to stay tuned with such content, hit the subscribe button below. Now, to take your learning to the next level, we have put together a free trial in which you can experience content in all the sections tested on GMAT Focus Edition. For example, you can build your CR pre-thinking skills, you can learn how to approach statistics questions in graphics interpretation as part of DI, you can learn everything about linear inequalities as tested on the GMAT Focus Edition, and a lot of other content. The link for this is in the description. Now, let's get back to the question at hand. So let's see, before we really jump into the statements, we should spend some time on understanding how she's going to minimize the probability. We have all the probability numbers, right? So if you look at A to B, the first leg of her journey, where is it that it's least likely for her to find this road construction? It is here, right, where the probability is 0. So route 2. Then you go similarly on the second leg, B to C, find the smallest value here. Again, we have a 0. C to D, when you go, the smallest you can go is 0.7, and that too, it's 3 different choices. In all of these routes, the chances of getting road construction, they are equal. So I can go anywhere. D to E also, the smallest value is 0.7, and I have 2 such routes. E to F, I have a 0 again. And F to G, yes, again, the smallest number is 0.7. This yellow thing, the highlights that you see, these are the choices. These are the routes that she will take because her goal was simply to minimize the probability, and that too according to her estimates. She may be wrong after all. Now, right now, because the values were very few, I could find the minimum values by just visually looking at it, but you can use the sorting feature that you have. So this is what the table is, right? And when you're trying to find the minimum, you will pick up each route, each pair of consecutive cities one by one, and you'll just sort it and then see where you're getting the minimum values. So if I sort A to B, for example, you see the smallest value comes on top. Then you do the same for B to C. Then again, the smallest value is 0. It comes up. Now, of course, you will not have the option to highlight like I do have here, but you can still get your values this way and make a note of them in your scratchpad. So again, this is your choice, simple work, you can visually see it, but again, just to be safe, this is a good idea to do it like this, use the sorting feature, because otherwise you might miss out, say there were 3 values and you probably saw just 1 value. So to save yourself from all of that risk, this is a good idea. So here I've just shown it to you for all of them this way also. Let's continue. At this point, let me ask you this. Could you have arrived at the approach of solving this question with this level of clarity had you not spent the effort in thoroughly understanding the information presented? Such is the power of the process of owning the dataset. And because this skill may not come naturally to many of you, we have created a course architecture that ensures that we teach you this skill through every guided quiz in the eGMAT DI course, and we reinforce the same in every practice quiz. In fact, the way we applied translate process skills so comfortably in this question, in the eGMAT course, you will learn how to build this translate process skill through purpose-built exercises. Thus, throughout the DI course, through around 500 questions, you will learn such process skills so that you can also comfortably use the owning the dataset approach. Let's now get back to the solution at hand. Okay, so let's read the first statement now. The probability that the sales representative will encounter road construction from D to E is 0.7. So D to E is simply this particular column here, and the probability that she will encounter based on her choice, yes, it is 0.7, because what is her choice dependent on? Only minimizing probability, and that minimum probability really for this column is 0.7. So the first statement is accurate based on our information, and so we will mark yes here. Let's read the second statement. Second statement is saying probability that she will not encounter road construction from F to G is 0.7. Important word here is not encounter. So F to G, you see encountering road construction, the probability of that is 0.7 because that's the smallest number. So if somebody does not read the word not, they will feel this is correct. Now think about it. This is about yes, I will encounter road construction. So what is the reverse of that, of not encountering? That's simply 1 minus 0.3. So this statement is not accurate. The actual value is 0.3. Finally, let's read the third statement. To the nearest hundredth, the probability that she will not encounter road construction during her entire journey. So it's not just saying any two cities, her journey is this. So again, keyword being not encountering this road construction. So let's see just what we did for F to G. We'll have to find this not encountering probability in all of them. So A to B, encountering is 0. That means not encountering is 1. B to C, encountering 0, not encountering 1. C to D, 0.7 encountering, so reverse of that. Every time I'm simply subtracting the number from 1. And these values that I have, the red values, these are the probabilities on the respective routes on these, between consecutive cities of not encountering any construction. So if I don't want this construction entire journey, then that means not on the first and not on the second and not on the so on, all of these different legs of the journey. So I simply have to multiply these values and I will have my answer. Now just multiply. You see ones obviously will not make an impact. 3, that's 27 and 27, but these are all decimals, so 0.027. Now obviously this is not exactly equal to 0.03 because they did say round to the nearest hundredth, and when you do that, it really is 0.03. So this statement is accurate and we're done. Now, to be able to answer this question correctly, we saw the importance of having strong conceptual knowledge. This was all about probability here. We saw two specific concepts. One was the non-event. So from the probability of an event, how do you find the probability of a non-event? Secondly, you also saw that we multiplied these different probabilities. There are cases where you add different probabilities. When is it that you add? When is it that you multiply? Basically, how do you work with multiple events at once? All of these concepts are taught in detail in the EGMAT course, and I'm going to show you a student's account for that. You are simply going to go from quant into advanced topics first. Now here in advanced topics, you have this module probability, the third one, and you can see these concept files. There is this third file called the non-event method, where one of the concepts we just talked about is covered, followed by a practice quiz on just that. Then you have another concept file on multiple events, just as I said, when you multiply, when you add, how do you deal with them? And then right after, you have a practice quiz as well. So every single concept like this is covered in complete detail in the. So if you do quant and verbal properly, you will have no trouble in DI.